Welcome to today's lesson on similar shapes. Just to get yourself started, can you figure out the blanks in these 10 questions? Pause the video now and then have a go. Okay, so if you were able to get that done successfully, you should have got the following answers. Firstly, 12, 35, 10, 5, 10, 1, 2, a half, 2/3, and a half. Today's learning objectives are as follows: to define similarity, to set up equations to find missing sides in similar shapes, and to explain and prove whether two shapes are similar. Now, how this all comes in handy is similarity is really helpful when drawing objects to scale. You can also use it to calculate the height of tall buildings without needing to measure them, but having something that is in the same proportion to measure instead. Now, as a definition, if two objects are similar, then one is an enlargement of the other. Corresponding angles are equal within the shape and corresponding sides are all in the same ratio. So for example, if I say that these two rectangles are similar, I can very easily see that the lengths go from 8 to 16 and the widths go from 5 to 10. Both of those work in a scale factor of 2, so to get from A to B, my scale factor is 2. Obviously, be really careful, because if I'd asked what the scale factor is from B to A, my scale factor obviously is not 2 in that case, it would be a half. To put that definition into practice, can you do some working out in your book to see if these shapes are similar? If they are, can you tell me what their scale factor is from the smallest to the biggest shape? Pause the video now to give it a go. Okay, so going through these questions, question number 1, not similar, because obviously to get from 10 to 45, I times by 4.5, that is not the same to get from 7.5 to 30. With the second one, yes, they are similar. The scale factor is 3. As you can see, 3 times 3 gives me the 9, 8 times the 3 gives me the 24. On the third one, again, not similar. To get from 5 to 6.5 is not the same as getting from 7 to 10. And finally, the last one, it is similar. There aren't any sides labelled, but remember that key part of the definition. If the angles, the corresponding angles are the same, then my shape is also similar. Let's try an example. Sometimes we need to find a missing side. To do this, we need to recognise our corresponding sides. Now, this is a simple example. It's really clear to see that 4 matches with 8 and 2 matches with y. Because my unknown side, that y, is on triangle B, I know I need to find a scale factor that takes me from A to B. I can then set up an equation by stating that 4 times my scale factor must give me 8. Some simple rearranging then would give me that my scale factor is 8 divided by 4, which is 2. I can then apply this because I then know that 2 times my scale factor must be y. I know my scale factor is 2, so 2 times 2 is 4, which means therefore that y must be 4. Sometimes it's not as easy to see what your corresponding sides are. In these situations, I suggest you take a different coloured pen and identify on the question itself which sides match with which. For example, I know very clearly that the hypotenuse here in red on triangle A is also here on triangle B. In between my angle and my right angle is 15. I know the matching equivalent to that on B is 6. I can then match up the final side quite straightforward. This time, my missing side is on triangle A. So I want a scale factor which takes me from B to A. Putting a similar process to the first example again here, that therefore means that 6 times my scale factor must give me an answer of 15. I can rearrange that, which gives me 15 over 6, which is 2.5. Having a look, I know then that 4 times my scale factor must give me y. I therefore need to do 4 times 2.5, which is 10. which means that y must be 10. Now it's your turn. Using your notes from the previous two examples, can you find the missing sides showing all the steps of your working? Pause the video now to give yourself some time to get that done. For this first question, I've already identified that I want to get from this shape to this shape because I've got the missing side here. Identifying the corresponding sides, I've got 2 here and 3 here, which means that 2 times my scale factor must be 3. My scale factor is then 3 over 2, which is 1.5. Using that to find my missing side, I know that 1 times my scale factor must be my missing side. 1 times 1.5 is 1.5, which means that x is equal to 1.5. Moving down the page to example number 2, again identifying the corresponding sides. This side matches with this side here. I still have a missing side down here, so I'm still going this way. I know then that 8 times my scale factor must give me 20. So my scale factor is 20 divided by 8, which gives me an answer of 2.5. Having a look, I've got 22 in L, which means that 22 times my scale factor must give me L. 22 times 2.5 gives me an answer of 55, which means that L is equal to 55. With question number 3, again, my corresponding sides are still here and here. This time, however, the missing side is here, so I want my scale factor to go this way. I always want to go towards the missing side. Setting that up, I know that 4 times my scale factor gives me 2, which means my scale factor is 2 over 4, which is a half. That therefore means that 5 times my scale factor is x. 5 times a half is 2.5, so x must be 2.5. With this last question, a little bit trickier. They identified some corresponding angles, and I'm going to use that to identify where my corresponding sides are. If I have a look, I have this side here, which is in between the double angle and the single angle, so I'm going to colour that one in blue. I have the same thing over here. I then have the side that I want, which is x. I'm going to colour in green, and that's in between the double angle and no angle. That's the same over here. That therefore means I don't actually care about the 4.9. Having a look, my missing side is here, which means I want my scale factor to go this way. I've got my matching size, which is blue, so setting up my question, I know I've got 2.6 times the scale factor gives me 9.1. My scale factor is therefore 9.1 divided by 2.6, which gives me an answer of 3.5. 3.5 times my scale factor has to give me x. 3.5 times 3.5 is 12.25, which therefore means that x is equal to 12.25. So, to recap, when answering questions on similar shapes, step 1, identify any corresponding sides. As I did in the examples, using a different colour just to go over the sides is really helpful. Step 2, double check which way you're applying your scale factor. You always want to go towards the missing side, and I tend to draw an arrow just to remind myself. Use a pair of corresponding sides to calculate a scale factor. The easiest way to do that is to set up a very simple equation and rearrange it. And once you've worked out your scale factor, apply it to find the missing end. That concludes today's lesson. In your books, complete the questions that are on the worksheet attached to this lesson. The challenge is to decide whether the triangles below are similar and make sure that you're able to write a sentence to explain your decision. The answers for today's questions will come up tomorrow. Good luck.